the topics. Good morning. We have started oil and gas separation chapters. So, two phase separator we have seen. Two phase separator means this is gas, this is oil plus water. So, when we are not separating oil and water separately, like we are assuming this is a liquid, so that was two phase separator. Okay, this was two phase separator. But if we separate oil and water also, then it will be creating a three phase separator. So, three phase separator means it is like this. Okay, gas, I am writing only G for gas, O for oil and W for water. And I am writing like GOW because of gravity difference is there. Water will have higher gravity, so it will be the bottom layer, and one more layer may be possible, maybe sand and other debris will be there at the bottom. So, we are not showing that one. We are assuming there are three phases only. Three phases means one gas phase and a liquid phase. Liquid phase has two component, oil plus water. Now, retention time. So, normally 3 to 30 minutes. Okay, 30 minutes retention time will be there. Okay, and the other terms it explain like free water. Free water, when you are separating and some water will be coming out automatically, so that is free water actually. Okay, so water fraction obtained from gravity settling is called free water. Okay, beneficial to separate free water before attempting to treat remaining oil in emulsion. Okay, so oil and emulsion you are separating means that will take more time. You have to use maybe heater treater, or you have to maybe use electrical systems. So, without using that one, only gravity separator is giving the water, that is called free water. Okay. So, coming from gravity separation, coming from gravity separation. Okay, three phase separator and free water knockout. So, another term is coming, free water knockout. Free water knock out. Okay, in free water knockout, what you are doing? You are removing. There is small amount of gas and you are separating. Okay, so that is called free water knockout. The terms used describe pressure vessel that removes water from mixture of crude oil and water, and gas amount will be lower. Very low amount of gas is there. So, oil and water separation. Okay, and you are removing basically water, removing water, okay, and gas is limited. Gas percentage is low. Okay, very low percentage of gas is there and you are removing water, so that is called free water knockout. Flow normally enters directly to separator from wellbore or wellhead, or it may be coming from other separator to your separator systems. Okay, equipment description, when you are saying, first let us draw one picture of horizontal, or any you can draw vertical separator also. So, equipment will have one diverter, right, as we are discussing already, inlet, flow coming from wellhead or different type separator, or high pressure separator to lower pressure. So, if you are going for high pressure to lower pressure, means one stage, two stage, three stage. The first stage will be higher pressure, then lower pressure, then lower pressure, then lower pressure. You can remember this stage separations technique. So, different stages will have their own pressure, but it will be lower than the previous stages, okay, and more than the next stage. So, this is inlet diverter, already we described diverter. If we have vertical separator, then maybe there will be one downcomer and spreader, we will explain later. Okay, and if you are using three phase separator, so normally this will be coming down to water level, inside water, and there may be some wear. Okay, this, so you are collecting oil here, and when you are collecting oil, you should have one dump valve and controller, right. Oil out, and gas you will have mist extractor, as you know. This will be pressure controller, right. This will be level controller. Okay, because gas we are not controlling level there, we are controlling only pressure. okay, but in liquid case we are controlling level, in which level it is working. Okay, it should not be too low or too high, so that level you have to set a minimum maximum limit. And there will be another layer, so this is oil, maybe oil plus emulsion, and this is water. Okay, and your fluid, entry fluid will be coming here. Okay, it will be entering like this. Okay, so slowly it will be coming down, and it will be going through water, and oil will be floating over water, and any gas is there, it will be bubbling up, and it will go through the gas outline or gas exhaust line. Gas out, oil out, and water, how will you take water? You are taking through another level controller will be there. Okay, water out, and this is actually when oil and emulsion layer level is going up, so it will be overflowing and it will be falling here. Okay, so this vertical one is called wear. Okay, wear. So it is restricting flow. When something is overflowing, it will allow overflow, but it will not when it is level is lower, oil level, so it will not allow to flow water to this bucket or this area. Okay, so whenever this area is filled, you are getting oil out. If this area oil is not there, again you stop dump valve, allow oil level out, level going up, again open it, going out. So continuously you are doing this job. Okay, sometimes you are stopping, sometimes you are opening, stopping, opening, so that work will go on. Okay, this is water, and this one, upper one, is gas. Okay, so this is called inlet diverter, and if I draw one vertical separator, so normally it will have one downcomer. So similar way as horizontal, you just turn it down, turn it up. This is inlet. Okay, and you will have again diverter, then you will have one downcomer, then one chimney will be there, it is called chimney. Okay, then there will be one mist extractor, right. So it can be like PC, pressure control system, gas out. Okay, and this is called spreader, in wider section, and lots of holes will be there, so it will be smoothly spreading. You are creating laminar flow. Okay, you are not creating lots of turbulence, so slowly, smoothly, whatever fluid is coming, it will be spread in water, and this will be located nearby water and oil interface. Okay, this is water oil interface, water oil interface. Okay, and this is water, and oil layer we can create one wear. Okay, this is oil. Okay, so oil will also have again dump valve, and you have one level controller. Level control symbol you can remember, LC we used to write. Okay, so oil out, and water again will create one level controller here, right. Level control will go like this, water oil interface. Okay, level control will go like this, just wait. Okay, no issues. Then dump valve controlled by this, and I will have one LC, level controller, is controlling the dump valve. Okay, this is water out. Okay, the purpose of chimney is to equalize the pressure inside this closed area, oil, water, gas. Okay, so if any gas is there, it will be equalizing upper part and lower part. And this is inlet diverter as usual, inlet diverter. Okay, inlet will be diverting, and slowly liquid will be entering here. Okay, free gas will be going out anyway, and if still there is some gas available, so again from water and oil layer, it will be bubbling up slowly, it will be going out also, because this gas chimney is there, okay, that equalizing port. Okay, so you can see this spreader. This is called downcomer. So downcomer will be there in vertical separator only, and there will be spreader because it's a long area. Okay. Okay. So diverter changes. It ensures the little gas carried out with the liquid or almost no gas. Okay, diverter will be pushing liquid down, so gas can go escaping. Most design contains downcomer that directs the liquid below oil and water interface. Just oil water interface, so it will be water washing. So the spreader location just below oil water interface, so that fluid will get water washed. Okay. If you are moving location to other part, then water wash will not be there. So just in water area, smoothly you are creating laminar flow, you are giving this spread. Okay, you are creating water wash. So water wash is the coalescing water droplets. So if there are lots of water particles are there, so when it is coming in water area, so water particle will get more water, so it will create bigger particle. When bigger particle is there, it will not move up, rather it will be staying there. Okay, so that way you are creating bigger particle, and you know the settlement formula Vt, right? So if you have larger diameter, so settlement will be quick. But in this case, it is in water area, so water particle will not move up or down because same gravity will be there. When same gravity is there, water particle will be staying there. You are spreading inside water zone, so you are making bigger particle, so it will be staying there. But lighter oil particle and gas particle, it will be moving up. Okay. The oil pad. The layer you are creating is oil pad actually. This is oil pad. Okay. Oil pad or layer. Okay, here also you are getting oil layer. So this is oil pad actually. How much thickness of oil and emulsion layer is there? This is called oil pad. Okay, oil plus emulsion layer forms a layer, and wear maintains the height of oil and emulsion layer. Okay, this you can see in both cases I have drawn wear. Okay, this is wear for vertical separator, WEIR. Okay, horizontal separator also I have shown on wear. So you can see side by side the difference of horizontal separator and vertical separator, that mechanical design actually. And few things are there I have shown like diverter, wear, but still there are so many items we did not show. Gradually we will show like wave breaker will be there, one vortex plate will be there, so that vortex will be broken. Okay, there will be a splash breaker. Okay, so some mechanical arrangement will be there, so the splashing will not be creating, rather it will be creating laminar flow, smooth flow, so that water and oil will get separated, but it will not be again mixing up. But you are creating too much turbulence inside separator, what will happen? Water oil particle again it will try to mix up. So you try to create laminar zone or calm cool zone. So actually in vertical separator you are creating more cool zone. Okay, so it will be good for solid separation. Solid particle will be slowly moving down, it will be getting settled. But horizontal separator, oil and water pad thickness is lower, thickness, vertical thickness. Okay, so it will have more turbulence actually. So solid settlement will be a little bit difficult. But vertical separator, you have thick water column, oil column. Okay, so in that case separation will be proper, especially solid separation. Okay. Where maintains oil level, level control maintains water level. Okay. So water, okay, level controller where both are maintaining water level or oil level. And interface I will draw properly here, oil water interface, so that you will understand. Oil water interface is here. Okay. So I made thick interface area. This is interface. And in vertical separator also I will be drawing one interface area. You can see I have drawn interface. Okay, This oil water interface area very important, because if interface is moving up very high, then actually wear water level will cross the wear. So oil outlet will get lots of water. Again, if oil level is very much lower, lower, then after certain time oil outlet will get lots of gas. So you have to maintain that properly, so that it should not get gas or water. So oil outlet should get only oil, water outlet should get only water. Okay. And again, the gas zone also, it should not be too small, like 50% gas we filled in two-phase separator we have seen. Now if it's growing smaller, that 50% to 40%, 30%, 20% gas area, then after certain time you will find in gas line oil is going out. Okay. So you have to maintain that level properly using UAR and using level controller. Now mechanical level control is there. These days there are electronic level sensors also there for automatic control systems. So, but first we are focusing on mechanical level controller. Okay. So if you understand things, then you use electronic or any other thing, that will be okay. So three-phase separator types. Types. Okay. So basically horizontal, we have seen horizontal, right? Vertical and free water knockout. This will also be vertical horizontal, free water knockout. This short form they say FWKO. Okay. And when you are talking about horizontal, again you will have basically three types they have defined. One will be like interface level controller, interface level, okay, and another is bucket and wear. So basically horizontal separator, there is some different fitting mechanism inside there. In that way they are differentiating, but everyone not differentiating, but some author has differentiated like this: bucket and wear, and another is only wear. Okay. This is boot type. Boot type. Okay. So interface level controller, it is like this. You have horizontal separator and you have inlet diverter. Okay. I am not drawing properly, I am just quickly I am drawing. Okay. And this will be longer and it will be going to water level. Okay. Inside water, this wear will go, and you will have one wear for oil. Okay. So this is oil, this is water, oil, gas. Oil means oil plus emulsion. Okay. And this is oil out, this is water, this is gas. Okay. Now when water out, we will have to put one interface level controller, right? And it is coming like LC, like this. Oil also will have interface controller, LC, level controller we write. Then okay. So level control will like this. So when level is changing, your dump valve will be controlled by level controller. Okay. So gas also will have pressure control system. So it will have like dump valve, then pressure control. Okay. Here PC, here LC. So don't mix up. Okay. So gas, this is oil. Okay. Now bucket and wear, what is the bucket and wear type thing? The bucket and wear type, like again draw your horizontal separator, you draw inlet diverter. Now you create one bucket. Okay. So bucket, this leg will be longer than this leg. Okay. So if you see A, B, C, D, so CD will be AB. Okay. And how it will work? It will work like this. Just wait. Okay. Some liquid will be coming here and your another wear will be here. Just wait. Okay. So water, and water is fluid coming here. Some fluid will go up, right? Some fluid is storing here. Some fluid will be going through this. It will be going. You are collecting. So this is water. Okay, and oil you are collecting here. So oil. So you are creating a small bucket. So bucket, if I draw in 3-dimensional figure, how to look like? It will be looking like just I am trying to draw. Okay, and your separator is like this. So completely you are blocking. Okay, so you may have this separator. Okay, so completely you are blocking half portion, let's say. Okay, one small leg, one larger leg. Okay, my bottle like this. Okay, you can assume. So perpendicularly like this. Okay, and your fluid is entering here. So when it is entering, so some fluid will be going through this, and one hole will be here. You are taking water out, not water. This is oil out. Okay, and inlet diverter, and fluid will be coming oil. This is what? This is water. This is water. Okay, so from diverter fluid is coming, and from below the bucket water will be going and will be crossing this wear, and you are collecting water. Okay, so this way. So your leg A, B, C, D. So AB and CD, if you see, CD will be longer than AB. Okay, then whatever oil you are getting, oil will be splashing, but it will not cross the CD, that deep D line. Okay, CDE maybe. DE it should not cross. If it is crossing DE, then actually water where it will get oil also. Okay, so actually, so your design should be like this. This bucket bottom portion will be lower than this water oil interface, lower than the water oil interface. Okay, then water will be entering below the bucket, then it will cross the wear. But if your bucket bottom part is more than this water oil interface, then oil also will go through this and it will cross the wear. Fine. Let us say one situation, I have wear here and water oil. Okay, and this is my separator and water layer here. Okay, so water will not enter cross. Okay, A, B, C, D. So in this case, you see this water out is not getting water, rather it is getting oil. You see this oil is continuously coming like this, right? So your bucket bottom portion should be lower than the interface level. Another situation you can see AB less than DC, AB longer than DC. So what will happen? Some let us say this case, if there is any overflow and dump valve is not working, then this will be overflowing and it will go there. Okay, so two things you have to remember. So bucket's bottom portion must be upper, and one leg CD will be longer than AB. Fine, then you will get proper bucket and wear arrangement. Then I should write like bottom portion of bottom of bucket should be lower than the oil water interface. interface. Fine. Okay, next is boot. So boot is like this. I have one separator. Okay, and wear is here, and you have inlet diverter. Inlet is here. So liquid will be creating one layer. Water layer will be here, and you are taking water out. Okay. And oil, water, gas. Okay, you can see this in boot case. You see one small, a large portion is there in separator. What happens? This will create very calm environment, so that oil particle will be moving up slowly, and water will be collected there. From there, small amount of water you can collect and you can separate. Okay, so it will not take larger space on your separator system. Rather, you are getting a small chamber where you are getting your things separated. Fine. Next is free water knockout. Free water knockout can be like vertical or horizontal. Okay, so you are getting more water and small amount of gas. Okay, so gas portion may be smaller. So separator section, gas percentage will be lower. Okay, and liquid percent will be higher. Okay, so these are free water knockout. So small gas, small amount of gas. Okay, and more. Okay, small amount of gas, and you are separating water. Separating water. Okay.